Hello, everybody. In question one, it says solve the equation and make your thinking visible in the unit circle and the graph. Okay, 0.3 is equal to sine of x. I know that the sine of x is our y value in the unit circle. So I'm going to start with that. My y value in the unit circle is 0.3. My y-axis is the vertical one. Where is 0.3 in this? I think it's right between 0.2 and 0.4. I'll put a little couple dots right there. I'm going to make a horizontal line at that height. Let's make that better there. There we go. And I'll give that a nice blue color. Okay, so I know that I'm going to have two places where I have a height of 0.3. And I'm going to circle them both. One will be in the first quadrant here, and the other will be in the second quadrant. And now down to my graph here, 0.3 is going to be a y value on here as well. So where is that on the y-axis? Okay, right in between here. So I'm going to make a line at that height right here. And okay, well, let's go there we go. Okay, my two intersections less than 360 are right here, which is before 45 degrees and between 0 and 45 degrees. And right here, between 135 and 180, which kind of matches up with my unit circle. One between 0 and 90 and 45, really. And the other between 135 and 180. All right, so let's start finding the first one by using our inverse sine tool. And I'm going to go to Google Calculator because that is just the easiest thing for me. And I'm going to type in, wait, let's see, what was it again? Sine of 0.3. So the inverse sine of 0.3 equals, 0.3. Oh, this is really not right because it should be in between 0 and 45 degrees, something a little bit bigger than that. And you know what happened? I put my calculator on radians and not degrees. I'm going to click that, make sure the degree thing is bolded. Let's just give that another try. Inverse sine of 0.3 is equal to 17.45 degrees. Now, does that make more sense here? 17.45 degrees, 17. Yeah, I can see that being true. So I'm going to mark that on my unit circle right here, that this angle right here is 17 point what now? 17.45. I'm going to round that up to 17.5 here. So 17.5 degrees. So that's going to be, let's see. Let's make that smaller. 17.5 right there. It's right there. Okay. Now that's my first solution right here. And that actually makes sense if I were to draw this down and see that, yeah, it's got to be below 20-ish here, closer to 20, though. It's close to halfway to 45 degrees. So 17.5 degrees makes sense for a few different reasons here. I'm going to just label that on my graph here too. I like seeing that all over. So now my first solution can be 17.5 degrees. Now, my second solution here, again, we got to figure out if I start at 0, how many degrees will it take to go all the way around to get to here? And I'm seeing that if I were to reflect this triangle that I didn't actually finish, but this triangle over, then I would get to my reference triangle in my second quadrant, which might help me out. Let's see if it does. I'm going to make this right here, and I'll label this angle 17.5 once again, and boom, 17.5 right here. So I know that if I were to go all the way around to the halfway point, that would be 180. But what I know now, I don't want that 180. I want only to this intersection point right here. And I know that right here is 17.5. So if I go to 180 and then I go back 17.5, I should be getting my answer here. So 180 back 17.5 is the same thing as 180 minus 17.5. So I'm going to put that down. I'm just going to put my work, I don't know, right here. It's not super neat, but I like to show it. 180 minus 17.5. And that's going to equal, I don't know what that equals. 180 minus 17.5 is 162.5. 162.5. That will be my second solution, 162.5. Let's check to make sure it makes sense in my graph. All right, if I drop this angle down right here, okay, it's between 135 and 180. 162.5 is, yeah, I can believe that. It's between 135 and 180 at 162.5. Thank you guys.